Hello everyone and welcome back to the channel. Isotope effect. This was the missing clue toward unlocking the mystery behind the conventional superconductivity. Yes, isotope effect is no doubt a quirky phenomenon, but without its discovery, we might never have understood the true nature of superconductivity, means actual reason behind superconductivity. We know this thing at present just by this discovery. This discovery was made in 1950 and experiment was done on the isotopes of mercury. Isotopes, isotopes, meaning of isotopes. For an atom here, protons, number of protons remain the same, but there is a change in the number of the neutrons. Okay, number of protons remains the same, but there is a change in the number of the neutrons. So those are called isotopes. So in the experiment which was conducted in 1950, heavier isotopes of mercury was chosen. Means heavier isotopes of mercury was actually used, and they found one interesting result, and that result is known as quirky phenomenon. What was the result? Critical temperature of superconductivity means it is the temperature of the material at which the material becomes superconductor. That temperature is known as critical temperature. So scientists experimentally found that when they made their experiments on heavier isotopes of mercury, they found that the critical temperature is inversely proportional to square root of the atomic mass of the isotopes. That means for heavier isotopes, critical temperature decreases, and for lighter isotopes, critical temperature increases. And this phenomenon, this quirky phenomenon, acted as the clue for the discovery of well-known BCS theory. Bardeen, Cooper and Schrieffer, together they discovered this theory known as BCS theory of superconductivity. In BCS theory, so this phenomenon, this experimental result, due to this experimental result, in their minds, in the minds of the scientists, this idea came. And that idea is at present known as BCS theory. And according to that theory, electrons in a superconductor form pairs known as Cooper pairs. But that is not due to the attraction of electrons, attraction between the electrons. That actually happens, means what? Formation of Cooper pairs. Formation of Cooper pairs happens due to the interaction of the electrons with the vibration of the lattices. And vibration of the lattices is known as phonons. Okay, lattice vibrations are known as phonons. Anyway, the formation of Cooper pairs becomes possible due to the interaction of electrons with the vibration of the lattices. So whenever you are using in your experiment, whenever you are using heavier isotopes, so heavier isotopes, in that case vibration will be reduced drastically. Means depending upon the mass, no doubt, depending on the mass, vibration will be reduced for heavier isotopes. So if there is a reduction in vibration, that means there will be a reduction in interaction also. So in that case, what will be the result? In that case, automatically the result will be a decrease in the superconducting temperature, superconducting transition temperature. There will be a decrease in that temperature. Because for heavier atoms, reduced vibration is there. That means reduced interaction is there. That means there is a reduced formation of Cooper pairs is there. Okay. And for that thing, there will be a reduction in the superconducting transition temperature. And that's why, for this reason, isotope effect is so important. Okay, because for this discovery that Beche's theory was possible, invention of or the discovery of Beche's theory was possible just due to this effect, due to this experiment. Though for high temperature superconductors, high temperature superconductors are there like cuprates. In that case, you won't get any effect of this isotope effect. Means that becomes actually weakens or yes, that becomes actually absent. In case of high temperature superconductors, there is actually no effect of this quirky phenomenon, means isotope effect, that either weakens or become absent. Okay, either weakens or becomes absent. Star effect, isotope effect, not star effect, it is isotope effect. That means in case of high temperature superconductors, some other phenomenon might be at play there. Okay, anyway, so this was all about today's topic. So what was the main focus of the study? This is useful for conventional superconductivity. Okay, not for high temperature superconductivity. For conventional superconductivity, this isotope effect is useful. This study is useful. Anyway, so this was all about today's video. If you found this video helpful, so please like, share and subscribe to our channel. And if you have any queries, please write in the comments below. So this is the end of this video. Thank you. Thank you for watching this.